Okay, let's take a look at the rationals review formula sheet. So, if we remember, obviously read the notes, watch the videos first. So we actually look for holes first. We factor the top and the bottom, and if anything crosses off, we set that thing equal to 0, substitute it into the simplified function to figure out the location of the hole. Remember, the domain and the range. For vertical asymptotes, we just set the denominator equal to 0 and solve. So whatever the denominator is, we just say that is equal to 0 and solve, and that's the location of our vertical asymptote. Remember, the domain restriction is x can't equal the vertical asymptote. For our horizontal asymptotes, we're going to have cases. Case 1, if the exponent of x is higher on the top than on the bottom, none. Remember, that might have a slant. Case 2, if the exponent of x is higher on the bottom, y equals 0. And if that graph is shifted up or down a c value, the horizontal asymptote is y is equal to that c value. Case 3, if the exponent of x is the same on the top and the bottom, y is equal to the fraction of the coefficients, 3 over 2. If that graph has been shifted up or down at all, the horizontal asymptote is y equals whatever the horizontal asymptote was before plus c. Remember, we're also going to be talking a little bit about end behavior. What is happening to x and y as we get really, really big? We're going to be finding x-intercepts by setting y equal to 0 and solving, and we're going to find y-intercepts by setting x equal to 0 and solving. We're going to find slant asymptotes by doing synthetic division and remembering that the answer is the equation of the slant asymptote. And we're only ever going to do that for case 1, when the exponent of x is the higher on the top than on the bottom. Now, keep in mind, we can always take a function and we can add and subtract fractions to turn it into a different function. Or we can take that function and we can do long division or synthetic division and turn it back into the other form. Remembering, for the basic ones, we simply want to use this form, where the denominator is the vertical asymptote and the thing off to the right is the horizontal asymptote. But if we have multiple things like x-intercepts, we want to use our a value to contribute to what the horizontal asymptote is.